Paul works for NEMA, that's a National Electrical Manufacturers Association. Their members produce all types of electrical equipment, the sales of which are more than $100 billion a year. And he's going to talk to you about the smart grid. Paul?
Thank you. And I'm happy to be here. My wife and I are both former students of George Mason, so it's great to be back on campus, although I don't recognize anything. This is our website, www.nema.org. A lot of the information that we're going to hear tonight is available from the website. You can go out there. In particular, I'm going to call your attention to this grid, this link, which is Smart Grid. And it'll take you out there, and there's several pretty darn good pieces of information out here. We've got some white papers and some old presentation, some information from past events. So if you're looking for more information about Smart Grid, actually, this isn't a bad place to start. And I'll have, at the end of the presentation, I'll have other links and sites that you can go to find out information about Smart Grid. So we'll start with the presentation. That's me. All right, so about NEMA, we're a dual-headed organization. We split our time between being a trade association, which is an advocate on behalf of the electrical manufacturing industry, and a standards development organization. So we're headquartered right here in Rockland, Virginia, and we've got 430 member companies, and they constitute everything from very small manufacturers, the small local folks, to the large international companies that you're familiar with. So General Electric, Siemens, ABB, they're all members of our association. And we all participate in the same mission, which is really to do basically whatever it takes in order to advance the cause of electrical manufacturing. Some of that has to deal with what happens on Capitol Hill and legislative. Some of it has to do with regulators, both at the federal and at the state level. And then lastly, we also get involved in we have an international group. We have somebody who focuses on international standards and their effect on what happens with the electrical industry. And then at the end of the day, we actually have three different lines of business that we provide to our members. It's government services, which is the lobbying and the advocacy that I previously mentioned. Technical services, which is the standards writing. And then we also have a business information services group who focuses on all of the information related to the manufacturing field. So I'm going to show you a little bit here about our product groups, and I can use this to explain how that business information services works. So this is about half of our product groups. We've got more than 50 product groups, and it's all organized vertically in the market. So you have people who focus on lighting systems. We've got power electronics. We've got building systems, and here's the rest of them. Power equipment division. We've got one of our product sections or divisions that focuses strictly on medical technologies. And then we have these cross-functional areas, which include high-performance buildings, smart grid, and energy storage. So at the end of the day, this ends up being me down here. But the business information services group that I mentioned previously, what they do is they actually go out and they collect information from these industries, and they provide it back to our members so that they can see where they fit in the marketplace in terms of market share, just compared to their competitors, where they fit in the industry. So it's actually a very valuable service that we provide. In terms of standards development, this is just our scorecard. We produce well over 600 standards and publications, and it ranges on everything. We've got testing procedures, all of the lighting. In fact, every time you plug into a wall outlet, you're plugging into a NEMA ANSI standard wall outlet. And these are actually NEMA 5-20 standard outlets out here because they've got the 20 amp fuse with the side hash on. So every time you touch electricity, you are touching NEMA. And this is the list of the various types of standards that we provide. So the first question that everybody asks is, what is smart grid? This is certainly a topic that's gotten a lot of attention since President Obama's inauguration because he mentioned about improvements to the infrastructure. We will build the roads and bridges and the electric grids and digital lines that feed our commerce and bind us together. So that was really his first public mention of smart grid. And then later in October, he announced a huge funding package for smart grid programs, $3.4 billion, which was awarded to 100 different companies. in order to implement these smart grid projects. So that was on October of last year. So we've gained quite a bit of momentum over the last couple of years. In fact, the term smart grid really didn't exist much before the year 2007. So the question, when you really ask the question, what is smart grid, you have to think of it almost in the same context of the internet. You know, if I ask you what is the internet, you have a notion of what that means, but really what drives it. I mean, the internet really is nothing more than a collection of standards. You're familiar with the Internet Engineering Task Force? You're familiar with the RFCs, request for comments? The request for comments really specify how every device in the internet is going to communicate and relate to every other device in the internet. TCP/IP networking addresses, all of that comes from a request for comments. Email, web browsing, XML, all of the things that we do when we touch the internet come from a set of specifications and standards. And that's the same thing that we're doing in smart grid. So we've got various electric standards for wall outlets, but what's missing is the higher level functions, the communications functions, the intelligent functions, the management functions that actually constitute the smart grid. And that's really more or less what it is. Some backdrop, where does smart grid come from? And actually the origins of this are rooted in two major events that happened in the U.S. If you take a look at the blackout of 1965, you can see it affected a major portion of the Middle Eastern seaboard all the way up into the Ontario province of Canada. 25 million people were affected over 80,000 square miles, and this was a huge event back in 1965. If you think about prior to 1965, or even prior to World War II, this was a very rural country, a lot of agriculture, there wasn't that much demand for electricity. Well, once the war ended, you know, we get into the happy years in the United States economy, and many electrical conveniences were being invented, blenders, alarm clocks. There was just a tremendous demand for electricity. And what happened is, eventually by 1965, in this portion of the country, of U.S. and Canada, the demand got so high that it actually outweighed the ability of the grid to supply it, and we had this huge blackout. So that prompted Congress over the next several years to have several hearings, and what they ended up doing is they cited a lack of research and development in electric power as part of the problem. And keep this in mind, because this is going to show up again when we talk about the next blackout. And what they did as a result of that, they said, well, either we can come in and regulate this industry more heavily, but what they did is they permitted the creation of this Electric Power Research Institute. EPRI is still a major player today, and their whole job was to a place where the industry could come together and they could do these common research and development functions to improve the quality of the grid. Now, as it turns out, several years later, the blackout was in 1975, or 65, this is in the early 70s. As it turns out, EPRI really launched the first smart grid project, and they called it IntelliGrid at the time. So they started to thinking about, as we're approaching the year 2000, they looked at the aging infrastructure that was in the grid and they said, we need to improve this. How can we as the industry, what steps can we take to improve the performance of the electric grid? So EPRI is a key player in what's going on. So you go from the blackout of 1965 to the blackout of 2003. August of 2003, we learned nothing.
It's the same area?
It's the same area, except for now we added Pennsylvania and Ohio, Michigan, but it's the same area. This time 55 million people are affected over 110,000 square miles. And again, we get into congressional hearings, what went wrong, why did it go wrong? As it turns out, it's the same problem. You know, lack of funding, lack of support in terms of the infrastructure. And this time Congress acted, and they act very decisively. The first thing they did is they, in the Environmental Protection Act of 2005, they went out and they said, okay, the Federal Energy Regulatory Commission is charged with mandating reliability standards for the electric grid. That's the first thing. So now what we have is some federal authority who has enforcement power over the quality of power in the electric grid. And that's a good thing. The second thing they did is beginning in January of 2007, they went and began to craft a bill that eventually was called the Energy Independence and Security Act of 2007, in Title 13 of which appears the term smart grid. So this is really where smart grid was born, in December of 2007. So we're talking about a business here model. In terms of government eyes, it's really just over 2 years old. So we haven't been at this very long, but what you're going to see is we've made tremendous strides in terms of our development and progress.